Hi everyone. Here we are back at question number 2 of this week's practice. Question number 2 asks how to find the number of terms in the following arithmetic sequence. The arithmetic bit matters because we're adding the same number. I know we're adding because we're increasing. Arithmetic always add or subtract the same value. So 64, 77, 90, and then how many times or what term do we get to reach 649? So what term in the pattern? If 64 is the first, 77 is the second, 90 is the third, what term number is 649 in this arithmetic sequence? So let's get to the problem. Here it is. So what we want to find in this case is actually a variable. We use the variable to represent the number of terms as being n. So I'm going to find n here. So a few things we need to find n. First, we need to find what this pattern or sequence is changing by every time. Because it's arithmetic, it has what we call a common difference. So d represents our common difference. To find a difference, we subtract two numbers. So to find this, I can take a number like 90 in the sequence and subtract it from the previous 77. Or I can take a number like 77 and subtract it from the previous 64. It doesn't matter which of the two terms we choose as long as it's a term and the one previous to it in the sequence. So these both result in the same number, which is 13. So here we know our common difference is 13. So now we need to set out and find, well, I'm going to add 13 over and over and over and over again. If I do this in the pattern, what term in my sequence is going to be 649? Is it going to be the 20th term? Is it going to be the 50th term? That's what we're set out to find. Now we could go through and say 90 plus 13 plus 13 plus 13 and keep track of that, but sometimes this will get overwhelming and we're going to be hitting plus 13 a whole bunch of times. So there's another way we can do this, and it's by thinking about how this sequence works and what it's doing every time, basically. So if I go from 64 to 77, I'm adding the difference once. So I'm adding 13 one time to get from the first to the second term. To get from the second to the third term, I add 13 again. So everything in these sequences is based off the first term. So if I think about to get from the first term to the third term, I have two differences here. So that's n minus 1, or term number minus 1 differences. If I were to go to the fourth term, which would be 103, to get from the first term to the fourth term, I add the difference 3 times because I'm already counting the first term here. I don't want to double count it and say I add 13 4 times. So what I want to think about here is 649 is the result of starting at 64 and adding 13 some number of times. Well, what we want to find is how many times that is. So we say n minus 1 because of how the pattern's built. It's always 1 less because I already have the first term counted here. So I add 13 n minus 1 times. To get to the fourth term, I add 13 3 times. To get to the 8th term, I'd add 13 7 times. To get to the 100th term, I'd add 13 99 times. So I do it n minus 1 times. And this is a formula that we could build in class, or you could have seen in one of the resources you were tasked with reading, watching, understanding this week. So now solving this equation, 649 is 64 plus, distribute here first before we do anything else. We have 13n minus 13. Collect our like terms. 649, 64 take away 13 is 51, plus 13n, subtract 51, subtract 51. I'm going to have to check on my calculator real quick what this is. 649 minus 51. This is 598 is 13n. Now divide by 13 and we get 46 is n. So there we have it. What we found out here is the 46th term in this sequence is 649. So we would have to add 64 45 times to get to 649. Go ahead and watch for the third video, which would be listed below.